Compare and contrast the short feedback and long feedback loop in the hypothalamic-pituitary axis. So in order to understand the feedback loops associated with the hypothalamic-pituitary axis, it's first necessary to understand how the hypothalamic-pituitary axis, or HPA, functions in the first place. And so what we're going to see is that at the base of the brain, within the hypothalamus, we're going to have nerves that are capable of recognizing and responding to a variety of stimuli within the body. Now, in this case, we're going to look at the ultimate control mechanism for the release of the stress hormone cortisol. And so what we're going to have is that cells within the hypothalamus are going to release a hormone called corticotropic releasing hormone. So it's going to be synthesized by cells up here within the hypothalamus. And even though it's illustrated on this slide as being kind of diffusing down and getting into the anterior pituitary, in actuality what occurs is that this corticotropin releasing hormone is going to be secreted into the connective tissue, kind of at the base of the hypothalamus, at the kind of the top of the stalk here for the pituitary. And it's going to get into a capillary bed. That capillary bed then is going to drain into a vein. So we have a venous portal system that is going to go into another kind of set of capillaries within this region within the anterior pituitary. Within the anterior pituitary are going to be specific cells that can respond to this adrenotropic releasing hormone because they have receptors on their surface. And so what's going to happen is the adrenotrophic releasing hormone is going to bind to the receptor, cause those cells that can respond to it to release adrenocorticotropic hormone. This is basically ACTH. ACTH is a whole lot easier to pronounce. And ACTH is going to be acting like the hormones traditionally. It's going to be released into the connective tissue within the anterior pituitary. It's going to get into the capillary system and then be circulated throughout the body. ACTH is going to act at a distance at a very low concentration, again, on cells within the adrenal cortex that have receptors for them. Ultimately, then, the ACTH is going to bind to the receptors within these cells in the adrenal cortex, the adrenal gland, and it's going to cause these cells to release cortisol. Now, what we look at with these negative feedback systems is the body wants to be efficient. It wants to produce the right amount of whatever the factor is at the appropriate time. It doesn't want to build up and produce a lot of it more than is necessary. It doesn't want to produce it and store it. It basically wants to produce just what is necessary. And so what we can see is that cortisol then is going to feed back onto the systems involved with controlling the release of cortisol from the cells within the adrenal gland. To look at this in a little bit more detail, we're going to look specifically at the negative feedback system. So in order to understand the feedback loops, both the short and the long feedback loops in the hypothalamic pituitary axis, the HPA, we're going to look at this slide. And so this is a little bit more of a schematic view than the anatomical view we had on the previous slide, but we've still got the same components. We've got the hypothalamus here, so the base of the brain. We've got the anterior pituitary, the endocrine secreting organ that hangs down from a stalk from the hypothalamus. And then we're going to have an exocrine gland. In the case previously, this would have been the adrenal gland. The adrenal gland cells that can respond to the hormones are going to release their hormone that is going to have the effect on the body that is going to act on a target tissue. But again, we want whatever this hormone is to be produced at the right amount at the right period of time. And so we don't want to have kind of an explosive release of it. We want to have a controlled release at the proper levels. Okay, so what we're going to see again is that within the hypothalamus, we are going to release or secrete releasing hormones that are synthesized by cells within the hypothalamus. These releasing hormones, though when act on cells within the anterior pituitary that have receptors for them. This is then going to release a hormone. In the previous example, this would be the ACTH, and we're going to go with ACTH because that's a whole lot easier to pronounce. The ACTH is going to circulate through the body and then act on cells in the endocrine gland. In this case, we were talking about the adrenal cortex and cells that can respond to ACTH by releasing the hormone cortisol. Now, what we want is for this cortisol to have an effect on the body. It's going to be a stress hormone. It's going to regulate glucose levels. And so it's going to have that effect. But we don't want to have kind of an uncontrolled release. And so what's going to happen is that that cortisol is going to do a negative feedback loop, in this case, a long negative feedback loop, and that the hormone that is secreting through the body is going to act on the anterior pituitary, as well as acting back here on the cells within the hypothalamus. In essence, what they're saying, what the cortisol is doing, is telling the anterior pituitary that the ACTH message got through and we are secreting cortisol. And so we don't need as much ACTH to be released. And so negative feedback, so as the cortisol is produced, we're going to decrease the amount of ACTH that needs to be released. And similarly, the cortisol is going to feed back further onto the cells within the hypothalamus and say you no longer need to be secreting that high level of those releasing hormones. And so we're basically turning down the production of the factors involved with the controlling the release of cortisol down here, the hormone down here. So those are going to be the long feedback loops. We're also going to have a short feedback loop that does much the same. So cells within the hypothalamus are going to be secreting the releasing hormone to cause cells in the anterior pituitary to release their hormone, in this case the ACTH. That ACTH will feed back along a short negative feedback loop to the cells within the hypothalamus that basically says, hey, we got the message. You no longer need to be secreting a large amount of this releasing hormone. We've already got the message and we are passing that message forward. So in both of these cases, we have a negative feedback loop that is regulating the production ultimately of the hormone that is going to have the effect within the body.